Okay guys, we are getting ready now for our circle chapter. This entire lesson today is going to basically be on the vocabulary we need to start off our chapter. So let's get right into it. Circle. Okay, let's talk about the definition of a circle. Circle is a set of points. Now, if you remember anything about circles, right, it's going to be an infinite set of points. An infinite set of points. So all these points, we have no idea exactly how many are, but there's an infinite amount of points on that circle. All right, so it's a set of points in a plane. Planes are flat. Okay, remember back from chapter 1, we talked about planes being flat. So it's a set of points in a plane that are a given distance, a set distance from a given point. Okay, now let's break that down. All right, so it's a set of points in a plane that are a set distance. That set distance is going to be the radius. That's a familiar term. From a given point. The given point is the center. So from this center point, the given distance out to any point on the circle will be the same. And that's what creates the circle. Okay, so the given point is the center, and the given distance in this definition is the radius. So it's a set of points in a plane on a flat surface that are a set distance, the radius length, from a given point from the center. Okay? The symbol that we use for circle is just a circle with a dot inside. So for example, if you want to name a circle, you call it circle and then whatever the letter is. Circle O, in this case, is what I have down here. That O represents the center of that circle there. And that's how we give the name to the circle. All right, let's look at the next definition, the definition of a center. Okay, it's the point in the middle of a circle that is the same distance to every point on the circle. We just talked about that, right? That center point has the same distance to every point that's on the circle. And of course, we also talked about the radius. Radius is that distance, that given distance we're talking about from the center point to any point on the circle. Now, one thing that we have to remember about a radius is that if that set distance is the same no matter what, that means every radius is the same length. And as simple as that concept is, you have to remember that throughout this chapter, that every radius within the same circle is congruent, equal. Okay? Now, this is an old concept too, right? We know that every radius is equal to half of the diameter. So 2 radiuses would give us 1 diameter. Half the diameter would give us 1 radius. So let's take a look at this picture down here. In this picture here, we have actually 3 different radiuses in this picture. We have OF is 1 radius. We have OE, that's another radius. And we have OH as our 3rd radius. So there are 3 radius lengths in this picture. And honestly, it doesn't matter what letter you start with. That could be EO or OE. It doesn't make a difference. And the same thing over here for each one of those radius lengths. But every radius here would be the exact same length. All right, now you guys are also familiar with the concept of a diameter. So in this picture here, you have a diameter that goes right here through that center of the circle, right through O. And we know that 2 radiuses make up 1 diameter. So EF, segment EF, is going to be our diameter there. But to really understand the definition of the diameter, you have to understand the definition of a chord. A chord is going to be a segment whose endpoints lie on the circle. So any segment in this picture that has endpoints on the circle is going to be considered a chord. So let's take a look. A and B are endpoints of this segment right here that is on those endpoints that are on the circle. So segment AB is a chord. Now that's not the only one. The diameter is also a chord. By definition, a diameter is a chord that contains the center of the circle. Okay? So the diameter is also a chord. So we have that on our chord list as well. And as you can see in this list over here, there is a 3rd one, CD. From this point C to this point D, from here to here, there is a chord right there. Segment CD is a chord. Okay, so we have to understand that we have several different types of segments within a circle. A radius is a segment, a chord is a segment, and also a diameter is a segment. All right, that's going to take us into our next concepts that involve lines. So if you take a look, a tangent is a line. It's a line in a plane that touches a circle in exactly 1 point. So it's actually going to be a line that skims along the outside of the circle because it's only going to touch the circle at one point right there. And this picture right here, that one point is H. H is called our point of tangency. Point of tangency is the point where the line actually touches the circle there. So line GH is the tangent, but H is the point of tangency there. Okay? So we have segments and lines. So one of our lines is our tangent. The second type of line we have is the secant. A secant is also going to be a line that touches a circle, but it's going to touch in exactly 2 points. So this line CD, all of this is our secant line. And it's going to go right through 2 points on the circle. It touches 2 points on the circle. Just remember something, though. That chord CD lives inside of that secant. And you have to be very, very careful with the way that you name the secant versus the chord because they're going to look very similar. Look at this. On our chord list, we had segment CD was a chord, but line CD is the secant. Okay? And the biggest difference between the chord and the secant is that the secant is a line and the chord is just a segment. So be careful with that concept. Okay? So go back and make sure you have all these definitions. Pause the video if you need to copy any of those definitions down. Okay, and we're also going to do the same thing with the diagram down at the bottom. Take a minute and pause the video if you need to copy any part of this down. All this information is important to help you to understand parts of circles. Okay, let's continue. Next concept we're going to talk about is the sphere. Okay, the sphere definition is very similar to the definition of a circle. The set of all points in space, though, that's the biggest difference, right? The circle was a set of points in a plane. This is space. Space gives our dimension. If you remember back from chapter 1, that's like our three-dimensional versus our plane, which is flat. So it's a set of points in space that are a given distance. There's that given distance again. That's our radius again. From a given point called the center. So from this center point, right, if you have the radius is coming out to any point, now this is a little tricky to draw because it's going to be like a ball coming outside, so it can be going anywhere. But anything coming out from that center there, touching a point on that sphere would be considered a radius of that sphere. All right, let's look at the next concept, congruent circles. Basically, congruent circles are circles that have the exact same radius length. So in this picture right here, these two circles are going to be congruent because they both have a radius of 5. So I can say that circle A is going to be congruent to circle B. Right? The circles are congruent because they have the exact same radius length. Okay, the next concept is concentric circles. And concentric circles is basically a bullseye. The definition here says it's 2 or more circles that have the same center. So it's going to be 2 or more. Right? You could have 3, 4, it could be an infinite amount of circles. It's a circle inside of a circle, right? That's what it is, a circle within a circle. But they have to have the same center, okay, to be considered concentric circles. And just a little quick note here, if this radius is 2, right, and this distance from here to here is 3, we know that the radius of the entire circle there would be 5. All right, that's a concept we might need going forward. All right, there's also concentric spheres. And basically, that's just a sphere within a sphere. So if you think of it as like a small ball inside of a bigger ball, inside of a bigger ball, right? That is the concept there of concentric spheres. But you have to just keep in mind, they all have to have the exact same center. So it's like the ball would have to be floating inside of another ball, inside of another ball. Okay, now, last concept is the concept of inscribed versus circumscribed. The word scribe means to write. So if I scribe something inside, that's inscribed. We are going to put a polygon and inscribe it in a circle. Polygon inscribed in a circle is basically a figure drawn inside of a circle where all of the edges of the figure actually touch the circle. So in this picture here, this quadrilateral actually has all of its vertex points, all of its corners there touching the circle. Okay, so we say in this picture that the quadrilateral is inscribed inside of the circle. Different from the concept of circumscribed. Okay, the word circumscribed means to write on the outside. The word circum means to go on the outside. That's that prefix there. Circumvent. When you circumvent something, you go around it. circumference goes around the outside. So when we scribe something on the outside, we circumscribe it. So circumscribed about a polygon is when you have that circle there in this picture that is drawn inside of a figure, okay, where all those points that you can possibly make touch that figure are actually touching the sides of the figure. In this picture, what you are actually seeing here is the square is circumscribed about the circle. Or you could also say in this picture that the circle is inscribed inside of the square. So this could go either way, right? You could have the circle inscribed in the square or the square circumscribed about the circle. It all depends on which figure you're talking about, really. Up in this picture here, you have the quadrilateral is inscribed in the circle, but the circle is circumscribed about the outside of that quadrilateral, okay? All right, so if there's any part of this lesson you missed, just go back and rewatch. One other quick thing I just want to mention real fast regarding these two concepts is you just have to be really careful, right? If I put my quadrilateral, that is not inscribed. That is wrong. It has to actually touch the edges. And likewise down here, if I put my circle just randomly in there, that would not be circumscribed. So just be very careful there to make sure all of your edges touch, okay? All right, guys, good luck.